My name is Mattie Mead, and I am the founder of Hempitecture. We are a company focused on building with a material that we believe is the most sustainable building material on Earth. So today we're going to talk about a few different things, but we're going to kind of get into our path. How did we get to where we are today? We're going to talk about some of the methods and techniques that we've been using along the way. We're going to talk about bringing Hempcrete to scale in the United States. What are some of the challenges and opportunities that are associated with this new and emerging industry? So before we can dive into any of that, let's get it out of the way and let's talk about what Hempcrete actually is. So Hempcrete is an insulating biocomposite building material derived from three natural materials: the inner wooden core of the industrial hemp stalk, a limestone-based binder, and water. So when we combine these things together in a very specific proportion, what happens is there's a CO2 absorption through a carbonation process. So this material forms itself when you combine the hurd, the lime, the water in a mixer. It solidifies by absorbing carbon dioxide. We're going to talk a little bit more about the carbon dioxide sequestration properties of industrial hemp, but about 1 cubic foot of the insulation material itself can absorb about 7 pounds of carbon dioxide. But where do we begin? I'm excited to put this in here because there's not many presentations that I could put this map up, and most of the people in the audience, I hope most of the people in the audience know where this is. But Hempitecture actually began as a research project at my college, Hobart and William Smith Colleges in upstate New York. I was an architecture student as well as studying environmental studies. Actually was having a conversation this morning about the impetus for my interest in environmental studies came from this area as well, understanding sort of the garbage issues that are here in this region with Seneca Meadows and some of the other larger scale landfills. So inspired by that, I wanted to look at ways that we can make a greener world. And when I was studying architecture, the two seemed like a good union. Why are we not often considering the built environment as part of the natural world? We consider them separate things when really the built environment has a great impact on the natural world. So this all started at Hobart William Smith College. When I was a senior, I started presenting on this idea of Hempcrete. But why? Why is this important? Well, there was one statistic in particular that really got me excited and really got me focused on this issue. And it was the issue of the impact of the built environment. So here in the United States, the built environment is responsible for about 40% of our domestic carbon footprint, as well as 40% of our energy consumption. So that's more than transportation, other industries combined. So when we look at possible solutions, we can't get to a good place without considering the built environment. The built environment presents one of the greatest opportunities for solutions. When I was at Hobart, the concept was actually much different than exists today. It started out as an interlocking building block concept, very similar to the Just Biofiber block that Jan was referencing from Alberta. However, this was in 2012 that I was talking about this insulating, interlocking building block. At the time, there were 0 industrial hemp, pro-hemp amendments in the United States. I was telling people, I think this is going to be the way of the future. We need to change our concrete masonry units. We can go to a structural insulating building block made from hempcrete, but concepts must be funded to become real life. So here's a younger, less bearded version of myself presenting Hempitecture in 2012 to a stage of venture capitalists, judges. I competed at all these different business contests, my colleges, the pitch, New York State business planning competition where we actually won the Finger Lakes winner in energy and sustainability. And the largest competition that we were in was the Global Student Entrepreneurs Award. Every single contest that we were in got to be a finalist. It was great to be on stage there. And this contest was for $10,000, this was for $50,000, this was for $250,000. We got 0. That's okay. Our business plan has pivoted since then, but just goes to show how fast things change. 2012, my family, my professors were saying, "You're crazy. What are you doing? You're really talking about building houses and habitats using industrial hemp as a building material?" And I was so convinced from what I had learned and researched and seeing how hempcrete's used across the world, that this could be a possibility. But again, there were 0 pro-hemp amendments at the time. All these venture capital panelists laughed and said, industrial hemp's never going to be legal, this is impossible. And then what you have is a situation like Canada surpassing us and creating a concept very similar to the concept presented in 2012 with the interlocking building block. So after all this, and after presenting this idea on the stage, not getting any funding or much support, one thing that did come out of it that was really positive was a lot of press, a lot of publicity. That press and publicity linked me to a place that at the time I really knew nothing about. I was just a graduate of HWS, and I got a phone call from a nonprofit organization in Idaho. This nonprofit organization said, hey, do you want to come out to Idaho and build a hempcrete structure? I said, I'm not really sure where Idaho is, but I'll consider. That sounds pretty good. So I took a trip out here for the first time to Idaho Base Camp. You can see the property outline here. Idaho Base Camp is an eco-retreat facility located in south central Idaho with a view of the highest mountain in Idaho. That's Mount Bora at almost 13,000 feet. I went out there, checked out the property, got familiar with the mission of this place, and the goal was to build the first commercial hempcrete building in the United States that would be an eco-retreat facility and would be an opportunity to get people to come up to this property, unplug, be out of cell phone service, connect with others, host retreats. We have leadership opportunities that happen there, but this building would really be the hub for all that. So went out there and started to work with the team on developing some of the designs. But going back to a similar motif of the funding that I got for the interlocking building block concept, this was a nonprofit organization who did not have any money. So how are you going to build a building when you don't have any money? You got to look for creative fundraising opportunities. To ensure that this building that we designed would be using and displaying hempcrete, what we did was we ran a Kickstarter campaign. We raised over $27,000 to fund the construction of this building. We had over 250 donors. A lot of those donors I had never even met, so it was a really awesome thing to see this interest coming from sort of a grassroots movement online. We were able to fund all of the wall material as well as the equipment expenses for this building from our Kickstarter campaign, and this was really foundational for us because without this project, this was truly our prototype experience. So we kind of worked through this floor plan. We knew how the building was going to be functioned. We took into account the solar pathways in designing the actual building. You can actually see we have a hydrothermal solar array here that pumps radiant hot water into the floor. This building is incredibly comfortable and is now used as this eco-retreat facility, as I mentioned. But what was happening during the construction process and the design, or prior to the construction process and during the design process, with that issue of not having money, your timeline gets pushed down the line. We're located in Idaho at 7,000 feet above sea level, and so we were hoping to build in July. Well, July soon turned to August, and then we were looking at September as the beginning of our start date. At such a high elevation, we get freezing temperatures. Hempcrete has an issue with solidifying with freezing temperatures, and so we realized if we're going to build this building, we got to do something different. We have to do something unique. So not only would this be the first commercial hempcrete building in the United States, we designed it using a prefabricated panel system. So what was able to happen was that all the work that was happening on the site and on the foundation, you can see here, simultaneously we had all of our wall panels already made. They were drying, solidifying, curing, and pretty much the week that the foundation was ready, we were able to take all these panels, pick them up with a forklift, drive them over to the site, and place them on the foundation. All told, we had all the panels on the foundation within 3 to 4 days, whereas the casting of the panels themselves took probably 2 to 3 weeks. We had a lot of great experiences with this method. We were able to lay a lot of these panels flat and cast the hempcrete flat, which cut down on our labor. That was a big saver for us in terms of time, because when you're building hempcrete conventionally, which we're going to talk about, everything is vertically. And so the first 2 feet are great. 4 feet, you're cruising. 6 feet, whoa, this just got a little bit higher, especially for me, I'm short. You got to reach over the panel. 8 feet to the top of the wall, it gets harder and harder. Jacob's laughing because he was at our hemp event in New York and in Geneva, and he saw that. It does get harder as it goes on. So this panelized method was a big breakthrough for us, as well as the first panelized system in the United States. The result, an incredibly comfortable, beautiful space with the central axis of the building designed to be in line with this bend in the Big Lost River. World-renowned fly fishing spot. We have people come up for fly fishing retreats. We just had a leadership retreat there where we sponsored 15 kids who had never left inner city LA and inner city San Francisco. We were able to fundraise for them to come out, spend a week here at Idaho Base Camp, connect with nature, do things that they've never done before, go rock climbing, river rafting, fishing, all these amazing things. And at the end of the day, the space that they get to be in and recount everything that they've learned is this incredible Hempcrete building that's built with 75% natural and recycled materials. So here's a view from Idaho Base Camp at night. It's a beautiful building. I would definitely encourage anyone to visit if possible, and that is a possibility. If you'd like to visit, I'm happy to set you up with the information. But after this project, as I mentioned, I went to school for architecture. This was a design build. I was responsible for being in the studio with the architect, designing the building that I was soon to build. After designing it, I went out there for the second half of the project. It's time to build. Once I started building, I realized, wow, they didn't teach me this in architecture school. And so spent some time after Idaho Base Camp furthering my education, getting more experience in construction, and remaining in Idaho, where I worked on custom construction projects ranging from 10,000 to 15,000 square feet. So this was a critical transition point where I was learning conventional construction methods and understanding how we do things, perhaps inefficiently, how we do things, and how we could better apply hempcrete to that. And so the next project was really the genesis of this sort of step forward in learning and understanding how things are conventionally done and how we could apply hempcrete to it. This is the next project that we worked on, and now the largest hempcrete construction project in the United States, over 3,000 square feet and 3 stories high. You can see that from just the drawings and plans here. The scale of this dwarfs the building that we worked on in the past, but was actually really similar to the scale of conventional construction that I was working on in Idaho, although a little bit smaller. But I got a call from Miss Pam Bosch, the homeowner of this house, and I was actually familiar with Miss Bosch already because National Geographic did a story on her about her little tiny house that she built as a prototype. They named her the grandmother of hemp, a title which she very fondly takes on. But it was a really unlikely team and an unlikely partnership. We have, a grandmother who is passionate about leaving a legacy, changing the way that we build, influencing that. She has grandchildren. She wants to envision a world where her grandchildren are going to get to experience a better quality of life or the same quality of life that she had. And then myself, a youthfully optimistic entrepreneur who's passionate to make this my career. So it's a combination of legacy and future that makes this project, part of it, so special. So when I first got to the Highland Hemp House, after agreeing to take on this project, figured, I've been framing for the last couple of years now. I've been trying to understand how we can apply hempcrete to conventionally framed structures. Why don't I go out there and I'll work with locally hired labor and I'll do the framing myself. I'll just back up real quick. I did live in that house for over 8 months. So I can attest to the abilities and the comforts of hempcrete, but this little tiny house is right next to there. So I woke up in the morning, pulled open my blinds, and I was at work. It was great. But worked on this house with locally contracted labor, and from the start realized, wow, this is going to be a lot of work. Actually spent the first week digging out bedrock from below the basement, and I said, this is not what I signed up for. I'm the framing hemp building guy, and I've got a pickaxe in the basement. This is not what I signed up for, but sure enough, we availed. This is about 10 days in. We have the concrete stem walls up, but part of the reason this picture is in here is to capture the view. This house is on the tallest hill in Bellingham, Washington, with a view of all the outlying islands, the Puget Sound. On a clear day, you can see good old chilly Canada all the way down to the Olympic Peninsula. And then out there, you can even see Orcas Islands, the San Juan Islands. So really incredible view. And it seemed like just about every day that we were building, we got a new view. We kept going higher and higher and getting more views, and here's kind of a photo of the framing in process. You can see that we had a 2-story clear wall, 3-story roof deck up here, but I distinctly remember the day that it was the, oh my gosh, what have I done moment. We put on all the roof rafters, we had some of the subfascia up, we just finished out this very challenging curved subfascia as well as roof, and I stood back and looked up at this building that I had spent, a couple months working on, and said, this is a problem. This is going to be a lot of work. The way that Hempcrete exists traditionally is that there's sort of what I call the bucket brigade style. I'm going to show videos of mixing Hempcrete, but oftentimes it comes out of the mixer and it's in a bucket. You then have to get that bucket from point A to point B. Point A being your mixer, point B being your wall. If you have a 3-story house, how are you going to get every single bucket, building in 2-foot successive layers all the way up to the top? It creates a lot of challenges, but a theme of this talk that I want to embody is challenges can also be opportunities. So what we did was we decided to apply a systems thinking approach. Systems thinking holds it's a disciplined approach for examining problems more completely and accurately before acting. The choices we make always impact the other parts of the system, and the principles of system thinking makes us aware that there's no perfect solutions. So that no perfect solutions point is important because we were looking at different systems from Europe, spray machines, these sort of more automatically dispensing Hempcrete projection systems. Well, an issue with those is that it increases the compaction of your wall material. So what does Hempcrete do? It's an insulator. The more we compact Hempcrete, the less R value and thermal resistance it's going to have, and the more less performing it becomes. Bellingham, being just south of Canada, has pretty strict building codes in terms of seismic as well as for insulation properties. Those projection systems, which would have cut down on our time probably by 75%, would have not allowed us to meet code. So we ruled that out. We could not use that into our system. So we had to come up with a new approach or maybe apply a different idea. So here you can see some of the working components that we have. It's not just about bringing machines and equipment together, but it's how machines, equipment, and people interact. Because if you have a limited number of people, everyone gets an hourly pay, or you're doing it on a bid, time is important. You can't just waste all this time. It's going to cost more money for the project, more money from the homeowner, and an unhappy homeowner is not a good thing. So what we have here in the first is kind of our mixing station. The mixing station had a drum mixer that was pre-mixing our lime-based slurry, which could then be dumped right into there. We had a remote-controlled operated winch to pull material up to the second floor. But really, part of the exciting innovation that we incorporated on this project was the conveyor belt concept. I'm going to talk a little bit more about that conveyor belt concept because that's really what I want to get at here. But this video shows the mixing process. Tommy, co-founder of Hempitecture, is mixing Hempcrete, combining the water, the hurd. That's our slurry mixer, which is actually custom fabricated with longer legs. so that it can be poured into that larger mixer, which is then feeding out our hempcrete onto a conveyor belt, which then loads up our buckets. We were able to use this conveyor system in a variety of different ways. This kind of gives you a sense of the scale of the house. But one of the exciting innovations was this custom stand that we developed specifically for the purpose of automatically dispensing hempcrete into our wall. So this stand was designed so that I could hold our conveyor belt and adjust to the proper height. We're form boarding hempcrete, so it goes 2 foot, 4 foot, 6 foot, and so on. This was designed so that the first height was 2 foot 4 inches. The next height was 4 foot 4 inches. And so it's automatically dispensing the hempcrete into the wall, which saves us overturning thousands of buckets directly into the wall, and then makes it easier for our guy who is tamping everything into place. So here's some of the results. This video shows it's a little tour of the house. Like I said, all of this had to be done in 2 foot increments with temporary form boards. What we found by doing a 2-week baseline of using the conventional bucket by bucket method and then switching to the conveyor belt system was that it cut down on our labor 50%. And so I'm pretty sure that if we had not invested in those conveyor belts, I probably wouldn't be here today because I'd still be packing hempcrete in Bellingham, Washington, and the house would not be done. Fortunately, the house is still done. I mentioned that the tops of walls are difficult. You can see how we're up in the rafters. It's one of the more difficult elements of a conventionally built cast in place hempcrete structure. But the homeowner is really happy with how it's turned out. This video also is going to give you a little bit of sense of scale. This is the 3-story wall that's on the north side of Hempcrete. We consulted with various different hemp building professionals, authors of books, and they said, I'd be pretty skeptical about building a 3-story hempcrete wall. And my response was, well, it's part of the architectural plans and that's what we have to do, so how can we make it work? Fortunately, we were able to make it work, but this wall actually accounts for about 30 to 40% of our material alone, just on this north aspect. Here's an aerial view of the building from the sky. I think it's over 43 or 40-something solar panels on this house. Multiple roof decks that are all designed to capture views of the surrounding Bellingham Bay. And then all told, we can break it down by the numbers. We used 12,000 pounds of hemp hurd, about 23,000 pounds of lime binder. It took about 1,500 labor hours, which sounds like a lot, but without that conveyor belt innovation, it would have been a lot more. And all told, this project absorbed an estimated 15,372 pounds of carbon dioxide. So what are the problems and what's holding us back? Again, I want to emphasize that problems can also be opportunities. Just because they're problems now doesn't mean that they'll be problems always. So what we have first is codes, building codes. Getting hempcrete projects permitted in the United States is really challenging. Every county that we work in, people that we consult for, we're essentially having the same conversation over and over and over again. What we're doing is we're explaining to a building department, to a planning department, we're explaining them what the material is and how we're using it. What is it? It's an insulator. It's non-structural and it's cast around a structural frame. It's fireproof, resistant to pests, termites, mold. Great. Can you show me evidence for that? Yeah, sure. We have tons of documents and research that have been done in the UK and in France and in the Netherlands and Belgium. Well, this is all in the metric system, so I can't read this. Can you get me something that I can read? Well, yeah, sure. Just do the conversions and it shouldn't be a problem. Apparently, that is a problem. In the United States, we need United States-based research to support this as a viable building product. There's an arrow connecting codes to legislation. We don't have an ICC code yet pertaining to hempcrete, but there's other different strategies for getting hempcrete into code. There's organizations like ASTM. For us, that's a lower hanging fruit than ICC, which meets every 3 years and revises their code. They actually just met earlier this year, and a hearing on Hempcrete was not introduced to this 3-year cycle. Another problem is processing. We are after a highly processed constituent of the industrial hemp plant called the hurd or shib, depending on geographically where you're located. This portion of the industrial hemp stalk has to be free of dust, as free of long fiber as possible, as well as processed to a specific length. Generally, we're looking for 1/2 inch or less particles, but anything less than 1/4 inch can be almost too light and too small that the density of the material increases. So your particle geometry is really important. As more people are looking to grow industrial hemp across the United States, they need a way to turn their crop into a profit. Part of that process is through processing. Processing is the way in which they're going to be able to separate all the fibers, the grain, whatever it is that they're looking to process, and then turn it into an end product. And right now, there isn't a wide network of processing facilities. There's a lot of discussion about processing facilities coming online in different places in the United States. Believe it or not, Kentucky has a modified processing system where they're using somewhat different processing equipment than is specifically meant for industrial hemp, but they're still able to get products that are somewhat well processed. Sunstrand is a company that's out of Kentucky, and they're kind of, in a sense, really leading the biofiber processing industry here in the United States. Canada, I believe, has a few processing facilities, one of which is, I believe, coming online in just north of Montana, above Sweetgrass, Montana. And the other thing here is economies of scale. So right now, this is about where we're at when it comes to Hempcrete. Inefficient industry participants. There's not a lot of people working in this space. We are one of the first companies that is licensed, registered, as well as insured as a Hempcrete-based contractor. That was no easy process explaining to our insurance claims adjuster what it is that we do. And in fact, for that, we pay the highest possible insurance policy rate that could be afforded. But as this industry grows, as more research and documentation is being created, we're going to start to come towards this area where there's processing more locally, where we can get material from, say, 3-4 hours away, as opposed to bringing in a container from Holland, which is where we imported all of our material for our most recent building project. It really doesn't have to be that way, but it is somewhat of a chicken and the egg issue for the farmers, as well as people investing in these pretty capital-intensive processing facilities. But the future is now. As I mentioned, when I started this in 2012 and 13, there were 0 states with any sort of pro-hemp amendment, and now just look how green the map has gone. My state of Idaho is still a holdout, unbelievably so, especially relative to perhaps even more conservative Utah. Idaho stands to gain a lot from industrial hemp processing, with it being such an arid climate. But the map is turning green, and that's really good news because that means that we're going to be able to get more of this material more locally, allowing us to create and nurture more local agronomies. One of the things that Hempitecture is doing as a company right now to support our mission of bringing Hempcrete to scale and creating opportunities for Hempcrete is we are partnered with Gonzaga University as advisors on one of the first United States-based research projects specifically focused on industrial hemp as a bioaggregate building material. So we're working with a group of 6 students from Gonzaga, as well as an advisor from Boeing, to study Hempcrete, study different formulations of the material, looking at more locally available possibilities. And the really exciting element that is now just developed is that Boeing, believe it or not, is going to allow us to use their burn testing facility. So we're going to be able to take Hempcrete composite samples made in the lab at Gonzaga, bring them over to the Seattle-Tacoma area, and Boeing, of all people, is going to put it in their burn facility and give us information and data on the results. So that's really, really exciting because that is one of the really important value-added benefits of Hempcrete, as well as a benefit that's super relevant right now, especially with all the forest fires going on in California. We also believe that education is a critical component and cornerstone to spreading the message, to letting people like you guys know who are interested in industrial hemp, the various different applications for the material. It's been an exhausting yet amazing and inspiring fall since pretty much August, where we did the hemp event in Geneva, New York, where we did a Hempcrete retrofit. Pretty much been on the road doing presentations, attending conferences. We were at Carbon Smart Building Day in San Francisco. We're at Net Zero 2018, which is a net zero conference in Los Angeles. And most recently, we gave a presentation to about 400 people at University of Washington for the Northwest Eco Builders Slam Summit. So what's the opportunity with moving towards more bio-based materials? Well, we talked about earlier about the two statistics of Hempcrete, or the built environment, being responsible for nearly 40% of our domestic carbon footprint, as well as nearly 40% of our energy consumption. Addressing climate problems is a multifaceted approach that requires attention to a lot of different areas. But there's a really interesting organization called Drawdown, and they actually list insulation as the 31st most important element of all elements to consider to address reducing atmospheric CO2 reductions by 2050. So we know that it's important to reduce carbon dioxide in the built environment, and we can actually transform our built environment to be functioning as biosinks for carbon dioxide. There's a large amount of companies now that are taking cement, concrete, and introducing carbon capturing processes to it. That shows that there is market direction towards using buildings as carbon sequestering biosinks. We believe that Hempcrete can play an important part in this, but it's not going to play a huge role until it's at scale. And so to get it to scale, we have to address some of these issues of codes, processing, as well as developing the economies of scale and local agronomy so that the costs of our material as well as the labor inputs can be reduced. And we know that by growing more of this, it's a good thing. We can support local farmers. We can reduce the amount of distance that the material has to travel, as well as create more hemp-based products, as well as hemp habitats using wooden hemp fiber as well as lime. So I've got just this video that I can play in the background if anyone wants to ask any questions, if we have time for that.
Yeah, we do.
So they actually spent last year doing this hop-based research project, and that's because to them, industrial hemp was still so controversial that they did not want their students focused on it. They basically developed the prerequisite for this year's study through last year's study, but from my understanding, that was quite a struggle. It does not perform the same way as industrial hemp, and so the students this year are excited to actually be working on something that could have an impact.
Is there an ISO standard?
Right now, there's not. We see that ASTM, fire resistance and thermal resistance standards, would be like the lowest hanging fruit to get those approved. And our students are looking at those standards when developing all their tests and conducting their studies.
Do you have any idea what the cost of a startup Hempcrete plant would
That's a great question. So for a company like ours, where we're actually mixing all this material on site, a good analogy that I like to use is it's kind of like baking a cake. You have the flour, you have the sugar, you have the water, and you have a recipe. You have to know exactly what proportions to combine them in. But if you don't have the right mixer, it's going to be a lot harder to make the cake. So we had invested a pretty significant amount of money into our mixing and conveyor equipment, about $20,000, which when I say significant, maybe significant for a construction company, but not significant for a larger company. But we're not a plant or a facility where we're pre-mixing this and bagging it and packaging it. We're basically sourcing these individual components separately to the site and then combining them. The mixer that you can see in this video was about $6,000. That's a higher end mixer for Hempcrete and specifically suited for the purpose. We're actually working right now with a company to develop a more affordable as well as higher capacity mixer for cast in place projects in the United States.
What do you do with raw product prior to the mixing process?
It has to be processed. You have to have a very specific type of hydrated lime that has a high calcium content. So that is then combined with your herd in the mixer. Often,
Talking about prior to that.
He's talking about the herds, like how to get the herds.
it has to be decorticated. So that's what I mean by process. It has to be decorticated, which is separated from the long fiber as well as any other plant constituent to just get that unique particle of herd that is free of dust and excess long fiber.
What would be compatible with that to use the outer fiber for it?
The outer fiber is used for anywhere from textiles to automotive components. In terms of a building application, it can be used in insulating bats. There are companies now that are making bat replacements, so similar to fiberglass bats. Hemp fiber-based bats are now being used.
So can you actually lower the cost if you're growing on the site that you're building the building?
Yeah, I definitely believe that the proximity principle, the more locally that we're able to source the industrial hemp and process it, the lower the cost is going to be. And really, in fact, the bulk of cost is not actually from the materials itself. The materials is definitely going to, the cost is going to come down. In both of our projects that we've worked on, the shipping cost has actually been higher than the material cost itself. But labor makes up about 75 to 80% of the cost component for Hempcrete. So depending on the project, it can be anywhere from $15 to $25 per cubic foot installed. So that's with labor. Obviously, a more sophisticated design or a design that has 3 stories like the Highland Hemp House is going to have a higher cost per cubic foot just because it's so much more labor intensive to get that material from your mixing station up to the 3rd story. Yes?
I had a question about the 3-story house.
Yeah.
How thick was that wall? Was it structural? And I guess I had a 3rd question, but I'll think of it.
Those are great questions, and while you think of those, I'll think of the last one. I'll answer the first 2. The wall is 12 inches thick, and it is cast around a structural frame. So there are some instances that Hempcrete can be used as a load-bearing component. However, not in this instance. We're just using it as an insulation monolithic wall infill material. But with that being said, there are some structural differences that a Hempcrete building evoke as opposed to a conventionally framed building. So oftentimes a conventionally framed building has plywood that is fastened directly to the studs. That plywood would give you your shear resistance. So that shear resistance is good for resisting the forces of an earthquake. In a place like Bellingham, where you have to have pretty high structural standards, yet no plywood, it was an engineering challenge. There might be some elements here that you can see. I'll point them out if possible, but without having plywood, we used a hybridized commercial style construction where we used X-braces, steel X-braces. So we framed the building conventionally, and we had certain spots that were open, and then we had these pretty significant X-braces that in certain spots, held together structural members. That was an engineering challenge because we had to then get the engineer who had never worked with this material before to understand the differences that this building would invoke and then how to address that. So the short answer is X-braces as well as internal shear walls. If you have any internal walls, you can use those as your shear walls to provide your resistance.
Also finishing materials, exterior and interior.
A hempcrete house can look however a homeowner wants it to look like. That aesthetic choice will drive decisions though from the earliest design phase. So for instance, if you wanted to plaster both sides of the wall, which this project was plastered on both sides, we put our frame to the center of our wall, meaning that we had 4 inches of hempcrete on either side of our studs. But if you wanted to have a more traditional finish, say like a wood-based siding, you could still do that, but you'd have to move your framing to the outside so that you had something to attach the boards to, if that makes sense.
And it doesn't affect the permeability or the insulative effect?
You're great. So you have to float the wooden siding out from the hempcrete so that there's at least a 3/4 inch air gap because the material itself is breathable. Thank you for touching on that. It's a breathable material, and so you're not going to have a conventional air barrier like a Tyvek or DuPont vapor barrier. The material itself is regulating of humidity and moisture, so it's breathable. You need to provide space for that moisture to ingress and egress from the wall system itself.
Along that same question, moisture absorption, thermal cycling, and freezing thawing conditions on an ongoing basis, what kind of work's been done by you and others to come up with those specifications?
That's a great question. We haven't really looked too much into that from our end. One area that you're really concerned about freeze-thaw cycles is during the curing. Curing can take up to 3 months. So when I was talking about that Idaho Base Camp project where we said, oh wow, we need to do something different, we have to have these panels so that we can avoid the freezing temperatures. That can significantly impact the solidification of the composite and that carbonation process. But in terms of freeze-thaw during the actual product's life cycle, I'm not familiar with any issues associated with that.
My question has to do with investment, startup capital. I loved your bootstrapping story, and I'm really curious what outside funding you've brought in, and what are your plans, for growth in terms of investor capital?
It's a great question. Thank you. We have not brought in any sort of investment money at all. We are entirely bootstrap financed to this point. Recently had a business partner come in who was able to bring a financial injection to help us make this next year possible, as well as diversify our team's ability. But what we're looking at is non-equity based funding. We're looking at different startup accelerators. We just finished a 10-week program with the Silicon Valley-based startup accelerator called Y School, which makes us eligible for a $10,000 grant. We're still waiting to find out about if we've received that $10,000 grant or not. Hempitecture has recently applied to the Echoing Green Fellowship, rather. Elemental Collider, Carbon 180, Y Combinator, Clean Energy Trust. We've been applying to any sort of non-equity based funding that we can possibly track down. So with that being said, if anyone knows of anything, Mass Challenge, yeah, need to apply to that.
One of the other questions I had, just to tie on follow-up question, was you done anything with Clean Tech Open? They'd be, I think, very interesting.
A colleague of ours just went to the Clean Tech Alliance brunch yesterday and brought up Hempcrete to a group of Clean Tech Alliance members in Seattle. And that was the first sort of foray and bridging of their mission and Hempcrete. So it's now on their radar. I'm just learning of that organization.
That's actually one of the many Clean Tech organizations, but the one I was referring to is Clean Tech Open. It's a competition for startup capital, non-equity.
Awesome. I'd have to look into that. Yeah, I'm just learning about the Clean Tech Alliance and that group recently. So thank you.
Sir, what
Oh man, hard questions. It depends. The total cost for the actual construction.
Yeah, to make it ready to move in.
$750,000. A large portion of that is not from the actual Hempcrete component. The Hempcrete component costs about $90,000 in total. $750,000 came from the fact that this house was actually a renovation addition, and we went to great lengths to build a very large new house on an old foundation, which had to be significantly rehabilitated. The basement was excavated from below the original house with new concrete poured.
So you took a legacy house.
Yeah, it would have been probably more financially feasible to just demolish the house, but part of the homeowner's intentions and mission was to save and preserve as much as possible. So not only was the original house disassembled, we reused a lot of the materials in the new house, which I wish I could say presented a great cost savings, but when you're actually denailing and taking apart wood, it adds a significant level of cost, and then trying to use that wood in a new construction also creates increased added time. This project was particularly expensive. It is very expansive, though. It's a big house. The square footage really doesn't even speak to the volume of the house because the ceilings are so high. Yes.
Congratulations on fire retardant features or benefits or?
Yeah, so Hempcrete is fireproof. We'll soon have better data for you on how to articulate that exactly once we partner with Boeing. If you just do like a standard at-home burn test, you could put a propane or gas torch up to a block of Hempcrete, let it run for the entire duration of the contents of that can, and the material itself will only char. You turn that thing off, you can touch the Hempcrete material seconds after. It doesn't fully ignite. There's been a lot of testing done in Europe that we reference when we're trying to get permitting processes happening here in the United States that show that it's got a burn length for, I can't remember the specific exact time, but it can be exposed to really high heat for a significant amount of time without degrading. Part of why that's also so important is that with it being an insulation-based material that is cast around a structural frame, all your wooden members are encased in Hempcrete. And so if your house was to experience a fire or some sort of tragedy like that, it's quite likely that all of your structural members would be encased by the Hempcrete and therefore be untouched by the fire. Yes?
I just wanted to congratulate you on really a great presentation.
Thank you.
Convincing pitch. You mentioned something about CO2 absorption. I thought that was fascinating from an environmental point of view. 7 pounds per square foot is what
Cubic foot, yeah.
And so that's what sparked my interest, is that you're probably really looking at surface area. If the wall's a foot deep, you're probably looking at absorption predominantly in that surface area rather than throughout the whole block, if I'm understanding the dynamics of that. And the question really comes, over time, in absorbing CO2, is there a change in the material in any way in terms of its brittleness or fire resistance? Has there been enough time to study that?
That's a great question, and so I'll address the first half of that. With it being a material that requires depth for its properties, that material is going to be uniform from the inside to the outside, and so it's the same material. It has to dry essentially from the inside out, but it's going to dry outside in. So through that process, the carbon dioxide is being reabsorbed through a carbonation process. Limestone is calcium carbonate. Once combined with the water, it wants to return to calcium carbonate, which requires the acquisition of carbon dioxide. But the carbon neutrality, negativity of Hempcrete, 95% of that is actually from the industrial hemp plant's growth and the carbon dioxide that is sequestered during the growth. That extra 5% is happening after the material is mixed and then cast into your wall and then is solidifying. Over time, the material is going to become increasingly stronger as it gets drier. And so what you have when you first mix it and you pull the forms off, it feels almost spongy and kind of wet. Often people liken it to Rice Krispie treats or oatmeal, but it does have this wet feeling that you could take your fingers and you could push into that material, but after the first week, you could knock on that material and it'll sound like a brittle wood. The wall will no longer flake, and you can start to see the individual particles starting to really bond together. The reason that the material composition works is for a number of reasons, but one of which is that industrial hemp hurd is rich in silica, as well as very absorbent. So it's able to absorb the lime-based slurry, which means that the cellulose and the pores of that industrial hemp hurd are being infiltrated with the limestone, which then, through the carbonation process, becomes inert. It is becoming less of like an organic material to more of akin to a stone or a pebble. Let me just get him first since he...
Regarding sourcing, do you find like the major bottleneck for your local sourcing, other than, is the lack of decortication and processing technology? That's the first part. Second part, we've seen in New York a lot of the licensing, majority of it go towards CBD production. As Jan touched in, and some of the varietals we're seeing sort of cross over into fiber and, leaving the flowers for CBD production. Are you seeing a merging of those models where we'll be able to source locally, say from some of the CBD growers with what's left of the herd?
Great questions, thank you. So yeah, part of it is definitely the processing issue, but it is, you're touching on a larger issue, which is all of the interest right now in the United States is for CBD. It's helping our cause in a way of indirectly promoting industrial hemp, but there's that awareness element that often people don't understand, that CBD varieties might not be conducive to being the sort of fiber varieties that we need as a material input. And so it's my hope that the CBD industry is creating an awareness and a collective consciousness of industrial hemp, which will have, people who would never consider industrial hemp prior, they now have it in their bathroom cabinets or are putting it in their morning coffee. And so I think that's going to expand the consciousness to what else can be done with industrial hemp. But right now it's where the money's at. And so it's difficult without, with the state of our industrial hemp industry, without any sort of national uniform farm bill yet to be approved, and without industrial hemp still being relatively controversial when it comes to banks. The fiber varieties are going to come later because it's going to require that extra processing. It's going to require larger scale. CBD can be done at a smaller scale, processed with smaller equipment. Of course, it can grow to larger scale, but the fiber varieties rely on that scale. And so no one's going to have a 2-acre, 50-acre just fiber farm, because you're not going to get a lot from that. So it's my hope that the CBD industry and the awareness that it generates is going to influence an upward trends that will transcend to dual fiber varieties.
Where do you stand on your interlocking block system, and have you looked into, your presentation was great on new construction, but retrofitting older buildings?
The interlocking block concept died close to when the venture capital panelists told me I was an idiot and that it was never going to happen and no one could ever do that. And there are companies out there like Just Biofiber who are doing basically something identical. I just visited a factory in Belgium called NYHempLab. They are producing about 2 million blocks per year in Belgium, but it's not likely that those blocks will be exported to the United States. A block facility also requires an investment up front. You have to have a lot of capital, which then begs the argument that there has to be the market demand. And so for us right now, it's a safer bet to focus on cast-in-place efforts. But our end goal as a company is not to be a construction company. We're in process of developing a variety of products to support the industrial hemp industry, from tools to mixers custom designed for the Hempcrete process, as well as providing equipment similar to the conveyor belts that you saw. So we're kind of focused more on supporting the industry as it can grow organically without having to take on the large overhead of being tied to real estate, block production facility, having investment capital in it. And there was another part of your question?
Just on retrofitting older buildings with
Yeah, we just did a retrofit project in Geneva, New York. Took an old building that was built in 1900s, a Geneva Row building, and we were able to apply about 80 to 100 cubic feet of Hempcrete to this back addition off of it as part of a upstate New York improvement grant for Finger Lakes-based communities. So it's kind of cool to tie in that grant to working with the Hempcrete project, as well as getting a community that for 4 years I was very involved in, getting them involved as well.
Well, folks, just come in. It is about lunchtime. If you're like me, then that's a priority. I want to say thank you so much, Mattie.
Thank you. Appreciate it.